Hello, I'm Ibrahim MASMANACI, and now I will present you the second assignment in the Augmented Reality course. First, let's look at the code for algorithm that is being attempted. I would like to point out that while trying to complete this assignment, we had several discussion meetings with the masters and doctoral groups with their permission, of course. Okay, in here there are two scripts. One of them is read point clouds script, which is used to read point clouds. The other one is the 3-point alignment script, the script that the algorithm runs on. Okay, here is the read point clouds. The reason why I put the scale factor variable in the read point script, because I try to implement the rigid transformation up to a global scale clause as far as I understood. I try to do this by entering variable here, the scale factor variables. When doing normal rigid transformation, I'm going to enter the scales of x, y, and z as inactive element, which is 1. But when doing up to a global scale, I'll change these parameters. Here is my other script. Okay. As I said, I added the scale factor variable here also to ensure that the point cloud is updated according to the variable we entered over there. Okay, I'm going to talk about these methods. Okay, the functions at the bottom are already available in the literature, and they are used as helper methods, and they haven't been modified. These methods which I mentioned is transpose, multiply, again another multiply methods, determinant, the quaternion conversion, as we discussed in our one of the previous class. The conversion between accord vector 3 to unity engine vector 3 and vice versa. Okay, let's examine the methods from inside to outside. It starts with here. And I took into account the scale factors here to create point cloud 1, actually to update point cloud 1. Okay, and when the user check the checkbox of run option, it updates method is triggered to the align methods. And here translation, rotation, and scale factor is variable is created here, and get best transformation methods come into play. And these methods accepts two lists of points, and which returns translation, rotation, and scale matrices. And here is the initialization of the best translation, rotation, and scale factor. And in order to select points, what we are doing is to get benefit from Brownsag approach. We select 3 of each points lists and take it as a vector 3. And we are just taking we are just passing the parameters to the get transformation methods, all the 6 points, and getting the translation, rotation, and scale out of it. And here is the count overlapping point method, which counts the inliers, the match points of these 2 point sets. And whenever the best in lies more than half of it, which is mean that is mean a 50% match has been gotten. Okay, the get transformation methods takes points, and here in this algorithm what we are doing is to calculate the centroid of each point set. Okay, the relative points are obtained by subtracting the corresponding centroid coordinates from the point itself, and there are 6 of them, and we are putting them into a matrix format. And here is the age. This age today also we have discussed in the class, the online class, the homography, which is obtained by matrix 1 times the transpose of matrix 2. And we are using the SVD algorithm, which is a singular value decomposition method. We apply this method to this homography in order to extract U, S, and V, the rotation, scaling, and translation matrix out of this. The rotation matrix is obtained by V times transpose of U, and we are checking the validation. If determinant is less than 0, we are doing the necessary operations. Okay, I talked too much. Let's make an experiment. The point cloud 1 is obtained from the point cloud 1 dataset, and the same applies for point cloud 2. Okay, now what I'm going to do is the rigid transformation without any scale factorization. That's why I entered as 1 everywhere. Let's run it. 7 and 500 times. Okay, let's run it. And there's a perfect match here. Let's just play with the parameters. Again, run it. It didn't work, I don't know why, but let's try one more time. I didn't save this scene, that's why, I guess. Okay, there's a perfect match here again. And let's try to enter different scale factorization here. 1 to 2 and 1 to 3 again, and save it. And in the alignment object also we enter the corresponding values. And let's play. And as you can see, the point cloud 2 scales up, and I leave as it is the other parameters and run it. And there is a verse output. As we can see from this perspective, 3, 6 and 8 alignment occurs. I want to do an experiment of the initial values again in order to get the different results from what I got in the first hand. Let's play it one more time and check the parameters. Okay. Let's run it one more time. Okay, we got different results as I intended to have. There are 9 at the bottom and 9 on the middle, totally 18 alignments. Okay, this was my experiment. Thanks for listening to me.